I'll just wait for you. And you tunggu dulu. I really hate, I don't know why with the Wi-Fi tonight. This is not, this is so important, and you really like to screw it over. Let's try this again. Okay. Let's see kalau aku try disconnect. Give me a moment. Okay. Lain je. Tahu kenapa. I don't know why this Wi-Fi is just want to go die. Okay. Let's on. So sorry for the delay. There's been long story short, my place is a bit bull crap. Nonetheless, I'm using data, so I have to consider that as well. Okay, before we move on, before we start, let me just say I've seen your task 3, and task 2 will be the last. I won't be looking at it anymore, but I will be. For next week, I will take a look at your task 4 and also task 1D as well, the extra one. Okay. For task number 3, many of you might not understand what I'm trying, the wording that I mentioned. So I have changed a bit. And I would like to ask you to redo it a bit. Where siapa pula masuk ni? Where basically, first of all, please write all tasks in one Python file. I repeat, all tasks in one Python file for week number 3. The second one is most of you, I think you misunderstood the word, misinterpret implementing with implementing that I meant here. Is actually I should have said you must call stack or queue functions from the created linked list, because you have basically for task 3B and 3C, you need, I told you to create push, pop, enqueue, dequeue, display list, and count. Okay, and you must use that internal that function inside the linked list, not as external. Okay, inside the linked list itself, you must call it to be used in the external function that I mentioned, the convert to array. Some of the groups understood the assignment. Some of you might not, but it's okay. I give you one more week for you to fix your code and Roger me when you have fixed your code. Okay. However, for task number 2, I think some of you probably overlook. So a point gone is a point gone. I won't be taking another look on your code again for task number 2. As well as task number 1, except 1D. 1D I just gave you, right? For task number 3, I give you another week until next week to fix your code. Okay? Okay. Let me see. How about my YouTube peeps? Okay. So without further ado, let us continue with chapter number 2, which is hash table. Okay. So basically, hash table, I'm not sure if you guys have looked into it or not, learned in your class or not. Long story short, hash table is basically a better version of you can call it a better version of array, where you can use strings as your key. Unlike the conventional array, where you can only give numerical value as its key, as its index. In dictionary, you can use what do you call it? You can use a string as the index inside the dictionary. Okay, as a replacement. So from here we call it as key instead of index. Okay, so how do you want to initialize? This is how you do it. Dictionary equals in curly bracket. You need to say the key. What is the key? Which is the name, which is DSA, data structure and algorithm. You have the semester as, and then you put the comma for another element. You have semester and its what do you call it? And its string, its value, the key time with also its value. If you don't give anything, you can just initialize as empty dictionary. Okay. So how do you want to print the dictionary? You can print the dictionary by just directly print that dictionary. If you want to get a specific data, you need to provide the key to the dictionary to get the data, to get the value of that key. Okay. So let's say I want to run this. Okay, assalamualaikum madam. I want to run this. So when we run this, so the first dictionary, when we print out, we get exactly what we initialize. Okay, the first value and the key, second key and its value, and the third key and its value. Okay, how to get data? Like this lah. You provide the key and it will returns the value. How to update the data? You can do the same. It's like a regular array. It's just that the difference is you can give a string. So dictionary in bracket, square bracket, single quote, name equals CIE. So basically you want to tell the array, the dictionary, I want this key which is named as name. I want the name to change to CIE. I'm not sure how about your current code, your current name of your course, but it's for now I'll just use CIE. Okay, and when I want to run it again, I can just call it again to get the value. Okay, so dictionary name double colon CIE. Let's say if you want to add the data. Okay, what you can do is the same thing. You can provide the key to the dictionary. This is how you add the data. You tell the dictionary what key you want to add, which is lecturer equals Dr. Rashida. So the value of the key lecturer in this dictionary is Dr. Rashida. So when we want to run it again, you get dictionary lecturer has the value of Dr. Rashida. So how to remove data? So there are several ways. Okay, there are several ways. So let's say I want to remove the time. So when we remove the time, so let us begin with this. So this is how you do it. Delete dictionary time. So you tell the dictionary what key do you want to delete. So let us just do this and do this and do this. Okay. So let us run this. So what will happen? It will give an error. This will put here. So when we run this, it will tell you an error. Traceback most recent call. So there's an error. Key error. Meaning that the key, the value from the value with the index time does not exist because we already delete the key. Okay. So back to here. So now what will happen if we want to clear everything? Okay. So let us try this. Let's do this. When we do this, we want to ask the dictionary what value does the lecturer key holds. Does the key lecturer holds. So we run this. We run this, and we see that the lecturer is missing. The value from the key lecturer is missing because we already clear the dictionary. So let us uncomment this, the print dictionary. So we run this again. It's still missing. So let us comment this. Okay. So when we run this, what is it? It shows nothing. Because basically you have removed everything from the dictionary, so the dictionary is now empty. Like that. What will happen if we want? So this is how you clear the dictionary. If you want to delete the dictionary entirely, you can just use the delete function. So when we do this, let me try to do this. When we try to run this, it says the name dictionary 2 is not defined. Do you mean the dictionary 1? So it says that dictionary 2 does not define because why? We already delete the definition or we already erase the dictionary 2 from the programming. So it is as if dictionary 2 does not exist. This will give an error because the object no longer exists. So that's what happened. So far, do you understand about dictionary and how does it differ with arrays? Understand? Understood? Yes, you are the mute man.
Yes.
Okay. So now let us see how do they operate behind the scenes. Okay. How how can you give a string or any kind of number, any kind of value into the dictionary and you can get a value? This is not an I know dictionary is not like an array, but how do they operate? So let us take a look at how do they do it. So this is how we do it. Okay, so what do? We introduce a class called hash table, and in that class, we want to initialize the size. Okay, so we initialize the size, self size equals to size, and from here, this is we want to tell the hash table that we have what is the size of this hash table. What is the size of this hash table? Okay, because hash table or dictionary is one of hash table, one example of hash table. Okay, so this is initialized, so we introduce the keys and the values. So this is just some regular initialization where it is none. So basically the key is none, and we times it by the size. And then we want to introduce the hashing function. Okay, I think I need to do some of this. Okay, so let's see. Let's say we want to create a hash table. Okay, so this is the hash table, this is the key, this is the value, and we also want to add another one, which is the index. Okay, it's okay, it's okay. So it begins with 0, 1, 2, 3, 2, 3, 4, 5, 6. So let's say the size of the index is 6. So this is how we are going to do. Okay, so let us create another one. Let's say this is the key and the value. So let us do this. So key, value, copy paste, 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 paste. Okay, for now, for this demonstration, I'm going to use numerical keys. However, during the task, if you notice, I would like to make you a bit suffer. So I would like you to implement the hash table that can hash string keys instead of numerical keys. Okay, so we'll talk about this task later. So let us look for this now. So for now we have key, let's say key number 20. We want the value to be yes. Key number 15, we want the value to be no. Key value number, let's see. I think better we start small. 2, 5, and then we have 9. We have 12. 12, yes. And we have, let's say, 21. Okay. Maybe we have the probably. We have so. Okay. So let's say we want to add this one by one. Okay. So what do we do? We have two functions that is important: the hashing function and the rehashing function. The hashing function is the function that simplifies our key into a size that can be accepted by the size of our hash table. Okay, as you can see, we have the key like 12, 21, but our index has only from 0 to 6. So that's the problem. So what we can do, for in this demonstration, I'm just going to show you that the hashing function is just you modulo the key with the size of the table. So the hash table hash function is basically key modulo. Modulo means we find the remainder when we divide the number with another number. Okay, key modulo size of table. That is basically our hashing function. Okay, so let us begin with this. So key value. So what index will we get? So what is the size of the table? The size of the table is 7. Size is 7. Okay, 1, 2, 3 until 6. 0, 1 until 6. Okay. So when we hash number 2, we get the remainder 2. So no problem. We can put the number 2 with the index number 2 here and the value to be yes. That's all. Next, we want to do for number 5. Number 5, we create the hashing function. We divide by 7. We get the remainder 5. We take a look at our index. Do we have number 5? Is 5 empty? 5 is empty, so we put number 5. We put no here because the value is no. Now we take a look at number 9. Number 9, we have index. We divide by 7. We get a remainder of 2. This is where we get into trouble because when we want to put number 9 into our hash table, we take a look at our index, we notice that number 2 is already occupied. So this is where the rehash function comes in. There are several types of rehash functions. We have the linear rehashing, we have the quadratic rehash, and the linked list rehash. Okay. The linear rehashing is basically you add 1 and then you modulo the size of the table. Modulo again. But remember, you need to add first and then you modulo. Okay. This is linear rehashing. Quadratic, for quadratic, I'm not sure. But I think I know how to do it. Okay. How do they implement the quadratic rehashing? It still uses the size of table, but probably it involves multiplying. For what do you call it? For linked list, basically you treat the value as the header of each linked list. So meaning that if you want to put 9, you put 9 here and then you put maybe. So 2 is the header, 2 and yes is the header, and then you need to find number 9 for the next one. Okay? So that's it. How about number 12? How about number 12? Oh, before that. Since 2 is not accepted, we rehash. So what we do, we plus number 1. We plus number 1, we get number 3. Do we have number 3? Is number 3 empty? Yes. Number 3 is empty. We put number 9 here and we put the value maybe. That's all. For number 12, we do rehashing, we get the remainder 5. 5 is taken, so we need to add another 1. We get 6. We take a look at number 6 and we see, oh, number 6 is empty. So we put number 12 here and we put probably here. Okay. And then number 21 divided by 7, you get a remainder of 0. Remainder of 0 is 0 here. So you put so. That's it. Let's say I want to put another one. I want to put another one, another key. Let's say I want to put another key. So what do? Let's say I want to put number 16. Number 16, when you divide it by 7, you get a remainder of 2. You cannot. 2 is taken, so you add number 1. You get 3. 3 is also taken. So what do? You add another 1. And you get number 4. Number 4 is taken, yes. And number 4 is taken, no. Number 4 is empty. So you put number 16 and we put yes there. And that's how it works. Like that. So let's say I want to change the data. I can just use the same key as before. So let's say I want to put number 2 and I want to change the yes to indeed. Okay. I want to change the yes into indeed. So we take a look at number 2. We see number 2 in the list. It exists. We can just change yes into 2. But let's say I don't want key number 2. I want key number 16. I want to change the yes into indeed. Okay. So what do we do? We take a look at 16. We go to number 2. 2 is the key at index 2 is not the same as the key that we want. So we check another one. We do the rehashing. We check again, not the same. We do the rehashing and we take a look. Oh, it is the same. Since it is the same, what we can do, we change the yes into indeed. That's how it works. Do you understand? So far, how does this works?
Yes.
Good. The others? I'll assume yes. But, brother, what happens if the hash table is full? Then we will say there's an error. Sorry, the hash table is full, so it won't be stored in the hash table because the hash table is full. Like that. Okay. So that's what happened. Okay. So now now we are done with this hash table. We go back to our coding. So we take a look. Oh, the hash function, it is the same. Key modulo self.size. So we take the key, we modulo it with the size of the hash table. Let's say if the slot is taken, we rehash it, meaning that we add another one, we modulo it again. Like this. Okay? So that's how you do it. Now, how about the get function? So we provide the key get function. So what do? We take the index equals to self.hash key. Okay? If the key is immediately found, okay, meaning that let's say we want to take number 2, we want to change, and we got number 2 as well. So we return the value of the index. Else, we go through the table to find the key. So this is where the rehash comes in. So what do? We take the OG hash, meaning that the original hashing equals to the index that is being hashed, and that index is going to be rehashed. Okay, meaning that we know that the original hash of number 9, let's say number 9, the original one is 2, but 2 does not exist. So what do? We save the 2, which is the original hash of the key number 9, and we increment by 1 and we check for others, so that let's say that if it goes one circle, it goes back to number 2. So meaning that the table has no key number 9, so it does not repeats again. Okay, so that's why we need the OG hash here. So while index is not OG hash, meaning that the index is already incremented by 1, so we do +1 and then we return to the OG hash. While index is not OG hash, we return the key. Else we return none, meaning that the table has no key that we want. Okay. Now we take a look at the put key. Same thing. A bit about the same thing. So they said if the index position has no key or the same key requested. So what do? So we put if the index, the current position is empty, or the current position has the same key as what we want, then we can just assign the value to that key, or we change the value on that position. That's all. Else we do the same thing. We create an OG hash to hold our index, and we make our index go through the table until it goes back to itself. So if the key is found, we change the value. If the key is not found, or the key is not found, or none of the positions are empty, we return the value. Uh, uh, we return that the hash, we say that the hash table is already full, else we return like that. And this is the set item. Oh, this is the delete key. So I want you to do this later for your task. Okay. So now for the demonstration. So from here, since I've already showed you this, okay, the hash table 7, h1, index is 1. Okay, now, since we have pretty much a bit more time, let us do some practice. Not practice, let us do some So what will happen when I want to run this coding with all this? Okay, what will happen? I don't want to, let us just ignore everything and let us focus on the last print h key, h values. Okay, meaning that after I put everything here, what will be the end product? So this is for you to practice. Okay, so I'll give this on the left side and I'll give this on the right side. Where is it?